Hello children, let us start third chapter, and that is complex numbers. In our previous classes, we have studied number systems. Number systems story starts with natural numbers. Counting numbers such as 1, 2, 3, 4 and so on up to infinity are called natural numbers. If we include 0 in this set, it becomes a set of whole numbers. That means 0, 1, 2, 3, 4 and so on up to infinity. If we include numbers on the other side of 0 as well, they become a set of integers. That means numbers between minus infinity to plus infinity, such as minus 2, minus 1, 0, 1, 2 are called integers. Then comes real numbers. Real number set consists of two types of numbers, rational numbers and irrational numbers. Rational numbers are those numbers which can be written in the form p by q, where p and q are integers and q is not equal to 0. For example, 1 by 2, 1 by minus 2, minus 1 by 2, they are called rational numbers. Irrational numbers are those numbers which cannot be written in the form p by q, where p and q are integers and q is not equal to 0. For example, root 2, root 3, root 5, root 7, they are irrational numbers. On top of the stack comes imaginary numbers or complex numbers, which we will study in detail in this chapter. Complex numbers are defined as the expressions of the form a plus ib, where a and b are real and I is equal to under root minus 1. It is denoted by z. So z is equal to a plus ib. A is called the real part and written as A is equal to REZ. RE is short form of real. B is called imaginary part and written as B is equal to IMZ. IM is short form of imaginary. Euler was the first mathematician to introduce the symbol I, which is iota, for the square root of minus 1. He also called this symbol as the imaginary unit. In z is equal to a plus ib, this is real part and this is imaginary part. So if b is equal to 0, z is equal to a. So the complex number z will be called as purely real. And if a is equal to 0, z is equal to ib. So the complex number z will be called as purely imaginary. 0 is both purely real and purely imaginary, but not imaginary or complex number. I is equal to under root minus 1. We will find out the values of I square, I cube and I to power 4. I square is equal to under root minus 1 whole square, and that is equal to minus 1. I cube can be written as I square into I. Value of I square is equal to minus 1. So it becomes minus 1 into I, and that is equal to minus I. I to power 4 can be written as I square whole square. Value of I square is equal to minus 1. So that becomes minus 1 whole square, and that is equal to 1. You need to keep these four values in your mind. In general, I to power 4n is equal to 1. I to power 4n plus 1 is equal to I to power 4n plus 2 is equal to minus 1, and I to power 4n plus 3 is equal to minus I, where n is integer. Now let us understand complex plane. In number systems, natural numbers, whole numbers, integers, and real numbers are represented on number line. But complex numbers cannot be represented on number line. They are represented in complex plane, which is very similar to 2D Cartesian coordinate plane. In place of x-axis, it is real axis, and in place of y-axis, it is imaginary axis. This is origin. Suppose there is a point A which represents a complex number z. Its real part is A and imaginary part is B. So point A can be represented by ordered pair A, B, and complex number z can be represented by z is equal to A plus IB, where A is equal to real part of z and B is equal to imaginary part of z. All the numbers which lie on real axis are called purely real, and all those numbers which lie on imaginary axis will be called as purely imaginary. This is Argand diagram. Now let us see equality and inequality of complex numbers. First we will see equality of complex numbers. Two complex numbers Z1 and Z2 are equal if and only if their real parts are equal and their imaginary parts are equal. Suppose Z1 is equal to A1 plus IB1 and Z2 is equal to A2 plus IB2. So Z1 is equal to Z2 if and only if A1 is equal to A2 and B1 is equal to B2. Inequality of complex numbers. Inequality of complex numbers is not defined. Suppose Z1 and Z2 are two complex numbers. If we say Z1 is greater than Z2, there is no way to verify that. For example, let's say Z1 is equal to 3 plus I and Z2 is equal to 1 plus 2I. So if Z1 is greater than Z2, that means 3 plus I is greater than 1 plus 2I. If we simplify this, we get 2 minus I is greater than 0 or I is less than 2, which is meaningless because we know I is equal to under root minus 1. Now let us solve a couple of questions based on what we have studied so far. First question, evaluate the following. Part A, I to power 135. Part B, I to power minus 999. Part A, I to power 135. We know that I to power 4 is equal to 1. So we will divide the given power by 4. We get 33 as quotient and 3 as remainder. So this can be rewritten as I to power 4 to power 33 into I to power 3. I to power 4 is equal to 1 and I cube is equal to minus I. 1 to power 33 is equal to 1. So it becomes 1 into minus I and that is equal to minus I. Part B, I to power minus 999. Minus 999 can be written as minus 1000 plus 1. So this can be written as I to power minus 1000 into I. Minus 1000 can be rewritten as 4 into minus 250. So it becomes I to power 4 to power minus 250 into I. I to power 4 is equal to 1 and 1 to power any number is equal to 1. So it becomes 1 into I and that is equal to I. Second question, show that part A, I to power 18 plus 1 by I to power 24 whole to power 3 is equal to 0. Part B, I to power n plus I to power n plus 1 plus I to power n plus 2 plus I to power n plus 3 is equal to 0. Part A, LHS is equal to I to power 18 plus 1 by I to power 24 whole to power 3. We will divide 18 by 4. So 18 can be rewritten as 4 into 4 plus 2. 1 by I can be rewritten as I upon I square. Multiply both numerator and denominator by I. This can be rewritten as I to power 4 to power 4 into I square. I square is equal to minus 1. So first term can be simplified as I to power 4 is equal to 1 and I square is equal to minus 1. So first term comes as minus 1. Second term, I upon minus 1, that is equal to minus I. Minus I can be rewritten as minus 1 into I. Now we will separate both. Minus 1 to power 24 into I to power 24. Minus 1 to even power, which will become plus 1. And I to power 24 can be rewritten as I to power 4 to power 6. I to power 4 is equal to 1. So second term becomes plus 1. Now minus 1 and plus 1 will cancel each other. So the answer is 0, which is right hand side. Part B, LHS is equal to I to power n plus I to power n plus 1 plus I to power n plus 2 plus I to power n plus 3. We will take I to power n common in all the terms. So in bracket we get 1 plus I square plus I cube. We know that I square is equal to minus 1 and I cube is equal to minus I. Plus 1 and minus 1 will cancel each other. Plus I and minus I will cancel each other. So in bracket we get 0. I to power n into 0 is equal to 0, which is right hand side. In next video, we will see algebraic operations on complex numbers. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.